Hello everyone, let's solve this fun one for today. In this question, we have to find the area of the semicircle. And the only information we have is there is two heights, one is 4 and one is 2 units. The distance between those two lines is 6 units. Using this information, we have to find the area of the semicircle. If anyone is interested, try to solve the question and comment on the answer. Before diving into the solution, let's look at the comment we got for our last video. Someone is asking to prove the straight line connecting the center of the semicircle and center of the quadrant passes through the point of contact for both these circles. Let's prove it. For your understanding, I shaded the straight line with the yellow color. Now I am removing all these things to prove the straight line passes through the point of the contact. This is the center for semicircle and this is the center of the quadrant, right? And take one more point, which is the point of contact for both the semicircle and the quadrant. Now draw a straight line passing through the point of contact. Now this straight line becomes the tangent for the both these circles, right? Draw a radius from center of the semicircle to the tangent. And now draw one more radius from center of the quadrant to the tangent. We already know for a circle, the radius and the tangent is at 90 degrees, right? So this one is 90 degrees and this one is also 90 degrees. If we add the both the sum, it is 180 degrees. Only in straight lines at any point, the angle is 180 degrees. Hence proved that is a straight line and it is passing through the point of contact for the semicircle and the quadrant. Thanks for the comment. Let's dive into our today's question. First, let's mark the center of the semicircle. I am naming the center of the semicircle as A and I am marking some more points. I am marking this point as B, this point as C and this point as D and this point as E. Now I am connecting the points E and A. Now I am connecting the points A and D. If you observe properly, can we treat EA and AD lines as the radius of the semicircle because they are touching the circumference of the semicircle and they are starting from the center of the semicircle. So both the lengths of EA and AD are equal. So EA is equals to AD, which is equals to radius of the semicircle. Now what is our main objective in the question? We have to find the area of the semicircle. We know the area formula for the semicircle is half times pi times r square. Here r is the radius of the semicircle. So to find the area of this semicircle, initially we have to find the radius first. Let's find the radius now. Triangle EBA and triangle ACD are right angle triangles, right? Because angle at B is equal to 90 degrees and angle at C is equal to 90 degrees. So this is the reason both these triangles are right angle triangles. And for these right angle triangles, AE and AD are hypotenuse. From using the Pythagoras theorem, we can find the hypotenuse of the right angle triangle, right? Let's find the hypotenuse. Before finding the hypotenuse, we have to make some assumptions because we don't know the lengths of AB and AC. We know AB plus AC is equals to 6 units. So if I am treating one of the length as x and the next one will become 6 minus x. So using these assumptions, let's find the hypotenuse of these right angle triangles. So from Pythagoras theorem, I am writing AE square is equals to AB square plus BE square. Previously we assumed AE as R, so R square is equals to, we assumed AB as x is equal to x square plus BE is 4 units. This is 4 square. Now I am writing the same equation for AD square using the Pythagoras theorem. AC square plus DC square. We assumed AD as R, so R square is equals to AC, which is equals to 6 minus x whole square plus DC square, which is equals to 2 units, so 2 square. Now can we equate both these equations because both the hypotenuse are equal, which is equals to R square. So x square plus 16 is equals to 6 minus x whole square plus 4. Now can we expand 6 minus x whole square as a minus b whole square, right? We know a minus b whole square is equals to a square plus b square minus 2 times ab. Using this, I am expanding 6 minus x whole square. So x square plus 16 is equals to 36 plus x square minus 12x plus 4. If we are adding up the numericals on this side, it is x square plus 16 is equals to 40 minus 12x plus x square. X square is common on both sides, so I am removing both of them. So what are the remaining things? 16 is equals to 40 minus 12x, and 16 to the right hand side, it is 12x is equals to 24, because 40 minus 16 is equals to 24. Now x is equals to 24 divided by 12, that is equals to 2 units. Now we are able to find what is x. So if you substitute the value of x in this equation, we will get radius, right? Let's do this. X is equals to 2. So I am substituting it here. R square is equals to 2 square, which is equals to 4, and 4 square, which is equals to 16. So r square is equals to 20. Instead of finding r, we can leave r square, because in the formula itself we have to substitute r square value. So if I am substituting this r square value in the formula of area of the semicircle, we can get the area of the semicircle. So area is equals to half times pi times r square. If I am substituting the r square here, it is half times pi times 20. It is 10 times. So the area of the semicircle is 10 pi. If you like this video, please like and subscribe the channel Messy Math. Thank you.